Okay, you can hear us, we can hear you, the computer is working, I can log into the whiteboard, everything is good. So we're in week 6 of Math E. We did our midterm last week. Everyone should know what they're good at and what they need more practice at. And have all the tools if you ever get the time to do all the practice you need. So we're ready to move on to new things, but new things doesn't mean a new math topic because we didn't quite finish with arithmetic with polynomials. So we had simplifying, we did, monomials we did, but we haven't done multiplying or dividing. And scientific notation doesn't really fit there. So we're going to just save that for kind of later. And when we get to some good application problems, then we'll do that. So that's where we'll start. And I did add a new, actually, let me look like a student. Better. Okay, I did add a new thing at the bottom of factoring polynomials. So we might get to that today, or we might not. Maybe it will be on Thursday, but it's ready for us when we're there. And I wanted to build it over the weekend because the reason that you learn to multiply is so that you can understand how they fit together, and then you can factor and break them apart. There's a few real life examples of when you might want to multiply polynomials. But one of the key things you want to do is find when things are zero. And with polynomials, we'll see that factoring helps you find out when they are zero. So if there's a path of a ball, when does it hit the ground? If it's losing money, when are you out of money? So when is it zero is a big question in real life often. And it might not actually be zero because you can sort of shift everything up or down by a certain amount. But when do you get to a certain value is a common question, and factoring helps you answer it. So there'll be more we see in like practical stuff once we get going, but there you go as sort of your warm up. So do we have any questions about class or procedures or homework or things like that before we dive in?
I mean, I'm hoping I'm not the only one, but I noticed that the midterm wasn't graded yet.
I wasn't going to put a grade on it since I was wandering around watching everyone and helping you when needed. And
All right.
so you have lots of other stuff that's getting graded and marked. So
Okay.
The midterm is an assessment, so you know how you're doing, not that anyone else cares how you're doing that week. Okay, so the whiteboard that we did had all kinds of stuff, but we didn't, where's the other stuff I had? Over there, okay. So this portion here is what we did 2 weeks ago, week 4 before the midterm. We were playing with small things that had X's in them. We were playing with how fractions work, things like that. Understanding exponents. So now what we're doing is moving over here, where for some reason the font gets much bigger because I'm not very organized. And we're going to do more things, but now we're going to talk about multiplying. And if there was one day during the ice storm that some people sort of came in to do a review old math topics thing, so you've seen a little of this before. Why is Zoom sending a message and it hasn't gotten the update screen? I am pausing if you can hear me, Vincent, Kayla, and Brenda. Something happened.
Yeah, we can hear you.
You can hear me. Zoom is just sort of restarting something. It's forgetting the screen share. And okay, were you able to watch me when I was moving things around on the screen before about in the Moodle where things were?
I can see it now.
Let me ask you again with the visual thing, when I talked about. Oh, computer is slow. There we go. When I talked about this factoring polynomial, were you able to look at, no, now it is dying again. Hello. Zoom is acting up. Wireless, very weak person. Okay, now my computer is back, share screen. Okay, so when we talked about the factoring polynomials, were you able to see the screen when I was sort of going over that overview?
I was not.
You are not. Okay, let me go over that then. So the arithmetic with polynomials is where we left off. And we have some multiplying and dividing to do before we're done with that topic. And then there's a new thing that we might get to the second half of today, or we might have to wait till Thursday about factoring. So when I gave a little speech about multiplying lets you get used to looking at factors, and that's what I was trying to point at. Okay, now I'll go forward. So the whiteboard has two halves. On one side, we had everything we did before with exponents and things like that. And now we're over here on this half. Okay, so I will have, let me get this part off the screen. Okay. I have two different multiplication things going on. They're both 31 times 25. And I want to point out how the color coding is making them the same thing, just written two different ways. So if you are an old fogey who rides dinosaurs like me, you were taught to multiply like the style on the left. I would start with 5 times 1 is 5. So I can't stand right in front of you. So I start with 5 times 1 is 5. And then I would go 5 times 3 is 15. And then I would go 2 times 1 is 2. And then finally 3 times 2 is 6. And then I add it up. 5 and 2 is 7, 6 and 1 is 7. Why do we have this spacer here, this 0 that wasn't really part of what we did? Where do we get that from?
The two is kind of 20 times 1.
Yeah, in 25, that's not a 2. This might look like a 2, but it's not, it's a 20. So this 0 keeps track of the fact that there's a times 10, because we're treating it like a 2, but we're wrong. We need a times 10 to get back to being correct. Now, if you were my kids, what they learned in a kind of more recent version of school was this Fox method. You take the 31 and you break it apart into tens and ones. 31 is 30 plus 1 across the top. And you break apart the 25 into 20 plus 5. And then it's like you're playing Battleship. We did some Battleship a couple weeks ago, so I know you know Battleship at least a little bit. In each box, you do the multiplication above and to the side. So 30 times 20 is 600, 1 times 20 is 20, 30 times 5 is 150, 1 times 5 is 5. Then you're not done. You have to take all those 4 boxes and add them up. So 600, 150, 20, 5, and you'll add them all up, and then you get the same 775 as before. My color coding shows you how those are the same thing. That this blue 5 of 1 times 5 is the same blue 5 as 1 times 5 over there. And this green 150 is the same as this 150, 30 times 5. We're kind of hiding the 0, but it really is 150, not just 15. And this red 20 is the same as this red 20. And this yellow 600 is the same as that yellow 600 from the 30 times the 20. So you can see how it all fits together the same.
Yeah.
Everyone okay with what I just did?
Do we have to do the box method?
Do you have to, not when you multiply numbers, but we're about to multiply polynomials, and then the box method is going to be more friendly. Because we don't really have place value. We're going to do several ways to multiply polynomials. And for most people, the box method will be your favorite. It's also the one that's easiest to compare to multiplying numbers in this more traditional left-hand way, so. Those are the 2 reasons we're doing it now. Okay, so if you really like this, then. Well, okay. So now on my screen, we have another version of that. We're doing 79 times 25. So especially if you are a Zoomie, then now you're after the midterm, used to being interactive. Grab the ones on the left and put them where they go here. Or grab the ones on the right and put them where they go there. And we'll see that we're understanding how it's 2 ways to do the same thing. Do you want, oh, I should be polite and put the link in chat, so you don't have to go all the way into Zoom. Zoom, Moodle to get this. Okay, there we go. If you just joined, let me do. Pull everyone towards me. Is it too hard to have my screen sharing while you're doing this?
No, the screen sharing is fine, I just was paying attention up there instead of down here.
Oh, I'm on the wrong week.
Did I join the right one?
I went to the wrong week, it's the.
That's not-
4, 3, it's 4 and
3,
6.
6, yeah. Arithmetic.
Or are we just moving them into the spots? then?
Yeah, move them in the spots.
Um.
And
Kind of
it's
disappears.
grabbing the same one. Or-
No, it disappears behind it.
Oh, well, then I need to go to this one and say, put it as the very back. So.
Yeah, it's super odd. I'm trying to
and-
drag the numbers into the boxes and it shows up on my end, but not everybody else's. So I think my Miro is having a difficult time
Could be,
synchronizing.
yeah. And there will be some overlap on the left. And that's okay. We can change which things are on top of each other to make it look as nice as we can.
There's just two of us, and no one of us here.
Here, I will finish off. Whoops, there's a. I just saw a syncing message, so things are not working. You need to take the red one and send it to the front. Um,
On week 4 and 6, right?
yeah. So they don't quite work on this left area because,
The midterm one, just the regular record.
Oh, I see.
yeah, don't use the midterm one, use the other one. So over here, it's awkward because we don't have transparency. So you kind of have to imagine how you would write it normally. But we get the gist of it, good enough. Okay, so. Now I'm gonna do the same thing with a polynomial. So if I want to multiply 3x minus 5 by 2x minus 1. Whoever wrote this, put them in parentheses, just to be extra clear that these are two different things while multiplying together. Then I want to put them on the box, just like we did before. The exact same kind of idea as multiplying with place value. But instead of place value, we have how many x's there are. Is there's no x's, like a minus 5. A plain x, like 3x or 2x. Is it an x squared? Is it an x cubed? So the power of x will replace place value for how you sort these. And the reason we do it that way is just because otherwise we can group them, right? If there was a minus 5 and a minus 1, and we're just adding those, that makes minus 6. Those aren't really two different things. But the 3x and the minus 5, we can't squish those together. They're different things. So that's why we do that. So I'm going to take my 3x. And I'm going to take my minus 5. And I'm going to take my 2x, take my minus 1. Everyone okay with how I'm setting this up? And now just as before, wherever the box thing was crossed, we multiply it. So what is 3x times 2x? 3 times 2 is 6. And x times x is x squared. Everyone okay so far? In this corner, a negative 5 times 2x. Negative 5 times 2 is negative 10 with an x. 3x times negative 1. Negative 1 times 3 is negative 3 and an x. A negative times a negative makes a positive 5. And like before, we're not done. We have to stick all of this together. And whenever we do it this way, then the only things that really stick together are going to be the two corners that have x's in them. Because those are always the same kind of thing, at least with polynomials of this pattern, right? Where an x and a plain number are in both of them. So those are gonna combine together. The others just kind of float around on their own. 6x squared. Now I have to think, if I am in debt 10x's. And I also am in debt 3 more x's, how big is my real debt of x's? 13. And a positive 5. Everyone okay?
Thought we weren't allowed to combine unlike terms. That's where I'm confused.
Tell me what you mean by combine.
Well, I mean, like 3x times -1. And most,
When we're adding, we can't.
right,
So if I am just looking at this 3x minus 5, that's as simple as I can make that thing. But I'm allowed to multiply anything. It might not mean anything, but I can. So that's why I'm combining them in this way, because I'm not, when we say you can't combine like terms, what we mean is add or subtract.
oh,
You can multiply them.
but why?
Why?
Yeah.
Let's imagine that we had. Why would we do this? All sorts of things. Great segue, okay. Why would we want to multiply polynomials? That's not quite why we're allowed to, but why would we want to? Sometimes they are measuring something that's real. So when we multiply the product, right, the result of multiplying is also something real. So area of a rectangle is length times width. If the length and width of some rectangle was changing, maybe it's not changing in front of our eyes. It might be a design issue. We're trying to design a room in a building, and this polynomial is the length and this polynomial is the width. And we're gonna fiddle with it and try and make the room the right size or something like that. Or maybe it really is changing in front of our eyes, who knows? But anyway, we could have sides of a rectangle that we want to express as polynomials and kind of adjust them some. If we did that, the area would be length times width, and we're multiplying the two. Maybe one polynomial measures speed and the other time. So speed times time is distance. If you want to know how far you go at a certain speed, then we're used to thinking of easy, like elementary school problems. A car goes 30 miles an hour, but you've driven a car. Do you stay at 30 miles an hour the whole time? No, it keeps changing, right? There's a formula there. Perhaps one polynomial measures something that's sold. How many lettuce wraps does your food cart sell? You know, as it gets popular, it goes up. And then the other is how much margin you make on each sale. So the product would be how much profit you get from selling your lettuce wraps that week or something like that. So there's lots of cases where we're measuring two things that are changing, and the product also has some real life meaning. In probability, we multiply two things to check the likelihood that one thing happens after the other. So the chance of getting two heads with coins is a quarter. It's a half for the first coin multiplied by a half for the second coin. So if we wanted to have two events that have probabilities, and there's some examples on the side that I don't want to really go into, but we could if you want. Then that's another case you multiply two things together. Too complicated to get into a tangent now. Lots of cryptography involves multiplying polynomials. If you want to make a code, then polynomials do that. So every time you send a text message, it's encrypted so that whoever, LCC wireless doesn't see all your text messages. So there's polynomials behind the scenes there. Lots of finance and biology applications involve change over time things. So inventories, banking, real estate, interest, retirement, population size, disease spread, lots of things like that. Anytime something is changing over time, it often changes in a way that involves polynomials, because in real life it's more complicated than that, and you can estimate it with polynomials. There's a whole branch of mathematics of how to take messy real life things and find the polynomial that best fits that shape. So then you could multiply those together. And then finally, as I mentioned before, when we multiply polynomials, that helps us with factoring them. And a lot of times we want to find when this formula equals 0. And checking when factors equal 0 is much easier than checking the big thing. Okay, did that answer your question enough?
Yeah,
Okay, so that little thing we're not using, let's go back to this part. So there's more than one way, procedure wise, to multiply the polynomials. So when I look here at the book for the distributive property. That method is when we think about what we normally call the distributive property and try and apply it in this situation. I didn't mention it first, even though it's first on the list, because for most people, this makes your brain sore and you want to forget I ever did this. So as a simple example, as a warm-up, if we just had 4 times 2y plus 3, then you could talk about distributing that 4 first to the 2y and then to the 3, and we get 8y plus 12. Everyone with me in that? That's how you've seen distribution happen before, when the thing we're distributing is just a plain number. But we can do exactly the same thing when we have a whole polynomial in front instead of just the number 4. So I could think about this as I take my 3x minus 5, and I'm going to multiply that by the 2x. And then I'm going to take my 3x minus 5, and I'm going to multiply it by the minus 1. I'm distributing the 3x minus 5 to the 2x, and also to the minus 1. If I simply keep going, 3x times 2x, 6x squared, minus 5 times 2, minus 10x. 3x minus 1 is a minus 3x. Negative times negative is positive. Do these 4 things look familiar? Yes, they're the same ones in the box. I'm just getting them in a different procedure, right? My method is different. Instead of making a nice box with 4 corners, then I am thinking about distributing in the same way I did before, but kind of more annoying because the thing in front now has 2 parts instead of just 1. Okay, I'm not quite done. I should write this as 6x squared minus 13x plus 5 to be done.
no, that's it,
Yep,
you going farther?
no, because x squareds and x's and 5s don't squish when we're adding and subtracting. We're to the point of adding and subtracting.
Well, what's 6x squared mean?
I don't know, it depends on the real life situation. It's something, whether I plug in x as time and that's how far I go. Or I'm trying to find out how big to make a room, and maybe I'll try 1 and 2 and 3 and see when the building falls over in my engineering modeling or something. So for now, they're just things on the board to play with, so we don't have an application. Whoops, and somehow the 5 disappeared over here.
So unless it equals something, you wouldn't solve for x.
No, there's nothing to solve for. We're just waiting to plug in something for x. Using the jargon from earlier in the term, these are expressions, they're not equations. There's no equal to something. We can't solve them, we can only simplify them. Okay, so just as a vote, who likes the distribution thinking more than the box thinking? Do a thumbs up or say something in Zoom or tell me if you're here.
I like them both for different reasons.
Okay,
I think the box is better on paper, but if you have a small one, I can easily do the distribution of brain.
I think the top line on the left. Way you did it is confusing to me. How you made it look like that compared to on the side down.
It's fair.
It was like parentheses 3x -5, and then 2x is out. Plus 3x -5, parentheses -1, like. I'm
Yeah, maybe if
confused.
I put parentheses there to make it more symmetrical, it would be happier.
But how are you, what do you do? I don't know, I'm confused by that. How
I'm
you
taking
went
the
there.
3x -5, and first putting it with the 2x, that's here. And then I'm putting it with the -1, that's there. So it's the same thinking as when over here. I'm putting the 4 first with the 2y and then with a +3.
Oh, okay,
But now I have a two-part thing that I'm smashing on.
okay, so you're distributing the whole. First parentheses with both
Yeah.
2x and then, okay.
Now, if you are mentally nimble, you could notice that there's nothing special about the 3x -5, just because I wrote it on the left. I could take the 2x -1 and distribute it. First to a 3x and then to a -5.
Hmm.
Okay, good news. Our next method, the FOIL method, is not actually a new method. Somebody said that, yeah, Isaiah's right. Kind of one advantage to the distributive thing is maybe you could practice it a lot and get better at doing it in your head. If you had to do a method without writing it down for some unknown reason,
Right.
then this method has more potential for that, that involves a diagram. So somebody said, what we'll do is we'll take. Okay, one moment, I'm gonna label things before I get ahead of myself. So this was distribute. Here was a diagram. So now we're going to do what's called FOIL. And FOIL is the same as the distributive. It's just that somebody said, if the goal of this is to be able to do it in our head, then let's make a pattern and always follow the pattern. And that's the easiest way to do things in our head. So FOIL stands for first, outside, inside, west. And all it is that there's 4 things that happen, whether it's the 4 corners of the box in the diagram method, or the 4 things that wind up happening in the distributive method, right? We're always gonna have those 4 parts, because we're combining 2 things with 2 other things. So what's first? The first ones are 3x and 2x. So we'll multiply those, so that's first. So 3x times 2x is 6x squared. Now we do outside, so the outside of this. See how those are the outside of the whole thing? So 3x times -1 gives us a -3x. Then we do the inside 2. A -5 times 2x is a -10x. And then the last ones of each, negative times negative is positive. Oops. Same 4 pieces. It's not like we're doing anything new, it's just a different mental way to organize it, a different visual way on the paper to write it.
Yeah, that one makes more sense to me.
And as before, if we have a common term, we can put it together.
Yeah, that one makes way more sense to me.
Most people like FOIL the best. But if I start with FOIL, you're not quite sure where it comes from. So starting all the way up with how multiplying numbers normally works, now you understand kind of. Yes, we're really multiplying, you don't just have to trust this process. And the last one, the place value method. You could try and write this like place value. I am not good at this myself. Let me see if I can manage it. It might just be ugly. We give up. But for you, I will try. One thing. There we go. Okay. So. Remember again, the amount of exponent on your x is what we're doing instead of place value. So we have 3x minus 5, 2x minus 1. And we're gonna multiply those. Let me actually use a different color so it doesn't look like another x. Oh, terrible line. Go. Okay, let's pretend we're doing place value. -5 times -1 is +5. 3x times -1 is a -3x. Put in our sort of 0. Our placeholder. It's the same thing. It's not that the 2 is a 20, like in our first example of the night. It's that we're never going to have plain numbers again. So there's nothing in this plain number stuff coming up. Okay, then this way, 2x times 5 is 10x, -10x, -2x. 2x, -5, there we go. And then 3x times 2x would be 6x squared. Actually, I'm gonna use the same color. There, okay. And then we add everything, 6x squared minus 13x plus 5. Okay, so 4 methods, same answer. That's what we'd expect because it's the same problem. And you don't have to learn all 4 of them. So pick one that you like and practice. If you're a typical student, they'll pick FOIL. That seems to be the most popular, but everyone's brains are different. You don't have to pick FOIL. Okay, questions about that?
Well, that makes sense.
Okay, if you think it makes sense, let's do some. So. Move to. Textbooks, yeah, nice textbook. And slow. Okay. I'm slowly over. I can't read on the silly screen if that's typed right. There we go, okay. Tools. So pick one for me to do, and then we'll let you work on them too. But I'll do one more for you.
36.
36. Okay.
Okay.
36 it is. Now, I could do this in 4 different ways, but. I'm only gonna do it in the ways that you asked me to, because. I don't. Want to bludgeon you with. Procedures that you don't care about.
I
Okay,
vote for foil.
let's start with Boyle.
Oils where we're probably going to use things.
Okay, so there's the 2 things. What are the first of each pair?
4x next.
4x and x, they're both positive. So there we go. It's gonna be positive 4x times x makes 4x, and another x makes it squared. So that was the first. Now, the outside edges of everything,
4x half.
4x and a half, they're both positive, so it's gonna be positive. So
2x, right?
yeah, half of 4 is 2, so 2x. Now, the inside pair. Negative 3/2 and x. If you don't like fractions, you could always put 3/2 as 1.5. Or you could put 3/2 if you like that better. I think for on the board, I'm gonna put 3/2 because. And if someone watches this later and wasn't here, they're not gonna look at the board and say, wait a minute, where did the 1.5 come from? Okay, last.
There's 3/2 times 1/2.
Yeah, is it negative or positive?
Negative. Negative.
It's negative, because only one of them is negative. We multiply fractions, multiply the tops, 3 times 1 is 3, multiply the bottoms, 2 times 2 is 4. The last thing to do is to combine these 2 terms. So we have 4x squared. So if I have $2 and I take away $1.50, what's left?
50.
Yeah, positive half of an x. Minus 3/4. The good news is that if you were asked this type of question, especially on the GED, they want to know, can you do one of these 4 methods? They're not going to give you terrible things with 7 decimal places and fractions that are ugly and have, 21/37
Yeah.
or things like that.
They were just gonna, you can do it.
Yeah, they want to know if you can do it, not can you waste time and do terrible fraction math. So they're going to give you easy fractions like quarter and half, 3/2, things like that.
Isn't 3/2 is 1.5?
Yeah,
Mhm.
that's why we had 2 minus 1.5, there's a half left. Again, if you want to rewrite everything as decimals and then go, you can always do that.
You can still be a fraction though, there's a whole 1. And the 1/2.
You technically do that, let's make a mixed number. Finish it.
I could make 3/2 1.5, yeah. I could rewrite it that way. I'm gonna leave it at what matches again, just so if
Yeah.
someone misses
Yeah.
class and looks at it, they're not all confused, but yeah. Okay, anyone want to see a method other than FOIL?
When your place value again?
Sure. So I write them one on top of the other, just like we're used to when multiplying numbers. Okay, so, whoops, not times. So, okay, yeah. So 3/2 times 1/2 One of them is negative, so that's -3/4. Then going this diagonal, 4x times a half, that's our 2x. Now we put our scoot things over reminder. X times -3/2 minus 3/2 x. 4x times x, 4x squared. So -3/4, 1/2 x. That's positive, and 4x squared. Ta-da. Ready to try one yourself? Okay, you don't have to do this on the awkward whiteboard. A big problem with this Miro whiteboard is there's no way to type exponents. So if you want to try this, I am not recommending this, but if you want to, then the standard kludge is to use a caret. And by a caret, I don't mean a piece of vegetable. But if you look at a calculator, it often has this little symbol that looks kind of like a mountain or something. So that's called a caret, C-A-R-E-T. And that's what people who want to do exponents but can't do exponents do ever since the days of typewriters. So I also put a space in between the half and the x because I didn't want it to be 1/2x. That would have been ambiguous if the x was part of the denominator, if there was no space there. So you can kind of do this in a official but clunky way if you wanted to on the whiteboard. But there was sort of a reason I wasn't sad that this wasn't on picture X. So on your own paper, pick which everyone can do, and then we can compare our work.
33,
33, everyone happy with 33?
pretty standard, easy one to practice on, I think.
Okay, I'm gonna put it on the whiteboard, just so we know which one. At least 2 loud people picked. Actually, I'll scroll back so that everything is on the board at once. So try 33. If you want, I can do it on the board in a moment, or we can just all look at our papers and say, yeah, that's good. And then we'll take our break, and when we come back, we'll do a little bit with division and then move on to the next topic. If you're a Zoomie, do like a thumbs up emote or type something in chat so I know that you have finished multiplying these out and we can move on. That works too, but you can raise your hand, that's fine. Okay, Brenda Vincent, do you want more time?
No, I should be all good.
Okay, anyone want me to do this on the board? And if so, what method?
Alright, let's do the FOIL method.
Oil, okay, oil gets the first vote. So we have first, the 5x and the 5x, 5 times 5 is 25, x times x, oops, is x squared. I can write what I'm saying, there we go. Outside, a 5x times a positive 4, yeah, positive 20x. Inside, a 5x times a negative 4.
Negative
Negative
20,
And then last, 4 times 4, but with a negative.
negative 16,
So we'll get 25x squared, the plus 20x minus 20x, that will go away. And we are minus 16.
Yeah.
Now, I'm gonna make a comment. I'm glad that you picked this one. Both textbooks have a little subsection called special products. And they will say, look, this is of a format A plus a B times A minus a B. They have a plus second, but same kind of idea. And the AB that's positive from the inside and the AB that's negative from the outside always cancel out. So we wind up with the first is squaring whatever's there, and the last is squaring whatever there, right? It's not that A and B necessarily have to just be a single thing. They could be 5x in the A spot. But that's how you write this sort of pattern. But I'm not showing you the patterns because one of the great joys when doing your homework over the next week is you'll notice some of these yourself and say, aha, if it's the same thing, but one is positive and one is negative in the middle, then the middle parts cancel out. And when you notice the pattern, then you start using it yourself, you feel like you own it, and it's much nicer than having someone just spoil it and show it to you. So if you like these patterns, then you can choose your grown-ups. Do you want to read the section about the special patterns and kind of, it's like peeking at the end of the book and seeing who did the murder mystery? Or do you want to just do the homework and see them yourself? And yeah, it's gonna take a few minutes longer because you don't know the shortcuts to start with, but then you feel good because you sort of discovered the patterns yourself.
I think I'd like to see the patterns.
So, okay, well, you have access to the books. Both books have a section on the patterns.
But,
You want me to show you where?
yeah,
So in this book, it is. Special products is the phrase they use. So 4.6. And in the other book. It is. Yeah. Polynomials, special products, 6.4. So it's called special products in both of them. Oops, why did it do that? So special products. Okay, it's a few minutes after 7. Keila has a kid to put to bed. I'll see everyone back in 5 or 10 minutes, whatever. It will pause the recording.
when you watch it as a child, like this is really brutal for a child.
Oh yeah, there's a lot of those where you just like, if you're a child, it's not that bad. Once you're an adult, you're like, I watched this.
Well, my stuff is canceled nowadays, children.
Is anyone else had it?
Uh,
An American Tail, five goes west, yeah, nineteen
Okay,
ninety.
while you were discussing old cartoon movies, I'm going to do 43. Everyone likes foil, most everyone. The problem with foil is that it only is what we call binomial, like bicycle, a two-part.
Was like, okay.
Multiplied by another binomial. So if there's ever one that has three parts, then you have to pick one of the other methods. So I'm going to do 43. The textbook, for some reason, oh, it doesn't, it just says multiply, so it's letting us.
Did you remember the record?
Yeah, I'm hitting record.
Oh, okay.
So I'm just gonna kind of write this out. I don't really know if it helps to narrate this times this is that, kind of see the mouse move, I think. But you can keep talking about your movies and how cartoons,
It's all good.
and them are more brutal than.
Nobody knows what movie I'm talking about,
No.
but it-
Well, yeah, I see that one.
it's kind of have that same old school. Like brutal story kind of deal, 'cause
Yeah.
it's,
Really have to have that warning in the beginning.
Oh, and the
this is
whole
gonna
movie.
hurt your feelings.
yeah, the whole movie is basically, it's all about immigration, but they just replace people with mice.
Wow,
And it's pretty intense. But
Well-
it's like coming to the West for the first time and
wow.
you're from like another country. And it was pretty-
Okay, if you want to call out and direct me, you can, but mostly I'm just doing this like as a background thing.
Another one.
In fact, I can tell you about
That's the-
the time that a Pixar movie traumatized my older child. He was very young. And so. We tried watching Finding Nemo and those poor fish
Oh,
never
yeah.
get a break.
Never.
And about the only thing he remembered after like hiding his eyes during as much of that as we tried to get through. Was that dentists are bad.
Yeah.
So it got to be my turn to go have my annual dentist checkup, and he was very worried. That this was not a good idea. So a few days before. We went to visit the dentist's office. And they gave him a tour and let him move the chairs up and down. For some reason, the thing that most impressed him was that. They had a stapler at the front reception desk. Anyone with a stapler apparently must be okay.
If you got a stapler, you're trustworthy, you're good.
And. So then I was able, 2 days later, to go back.
Also,
And get my teeth cleaned, and he was not panicking at home the whole time.
like hummingbird.
And they-
Did I put too much of the?
No, it's actually pretty good. The gingerbread's pretty good with it. It's just dry and I need something to drink.
Okay, when I first made up this recipe, we had a different gingerbread spice mix, but we upgraded for holiday baking. Okay, so there's using the place value method, because that seemed to be our second favorite as a group. Of how you can multiply, even if one of them is what I will call a trinomial, like tricycle, it has three parts instead of two. So. We can still do this, it just, we can't foil it, because the particular foil pattern is just.
So the foil wouldn't work for this.
No, because it talks about first inside, outside, last, and it like skips over this minus 3A or something, right? So. You could make some other acronym for all of the ways that,
Could you do distribution?
yep, you could do distributive, it would be the same thing, we would take. The -3 and apply it to everything. We would take the A and apply it to everything, we'd squish it together, so you'd have the same 6 pieces. It would just look like a line instead of 2 different rows. Okay, now I'm gonna pretend we're really done with break. I'm not sure that anyone will ever ask you on any test to deal with trinomials. They're kind of in the book for historic reasons, not because it's a GED prep specific textbook.
Okay. No.
Okay, the last thing is about division. So. if I have. Let's not do. 20/4. You know that I could write that as 5 times 4/4. 4's cancel. And we get 5/1, which is 1. I could also write this as 20/4. Let's divide top and bottom by 4. Oops. What am I saying? And then we get 5/1, which is 5. Everyone happy with both of those things? Okay, Zoom crowd, are you back from break?
Yeah, I'm here.
Okay, I see hands, thank you. We can do the same thing with polynomials. And to be ready for the GED, we can be wimpy. The only thing we need on the bottom, on the denominator, is maybe a plain number or maybe something with an X. We're never gonna do even a 2-part thing, a binomial. So if I had, instead of these. Twenty X over X, what would I do?
Actually, the one,
Yeah, the X's would cancel out, same as those 4's. Because this is a times in there, right? And I would get 20/1, which is 20. What about if I had 20X over 4X?
Similar, but not quite the same. Once you add, I mean, the x's would still cancel
The
out,
X's would still
but
cancel.
then you're just left with having to solve the 20 and the 4,
Four.
which leaves you at 5.
Yep, so the 4's would cancel, and we get a 5 and a 1. And last permutation, what if we had 20X over 4?
The x is gonna remain, and you're just gonna be left with pretty much 5x at the end of it.
You don't have to write this middle part with the something over 1, I am just doing that because I'm lecturing.
Whiteboard stuff.
Okay, everyone okay with that? So, ta-da, that kind of thing, so you can do that. I don't wanna make a big deal out of it, cause then you'll someday make it harder than it is.
can we do it with numbers that don't like each other?
I'm not sure they will ever actually do that. What they will do sometimes is put a binomial on the top. So let's find one from the homework. That. You can pick, dividing a polynomial by on. Okay, which one of
Oh,
those?
29, that's crazy.
29 looks crazy. So up above. I wrote things as the factoring products, right? So way up here, I factored things before I canceled. As opposed to over here where I just jumped right to cancel it. See the difference? If I write the factors, then it's easier to see what's going on. So I'm gonna back up, because this looks crazy. It's actually not hard. But because it looks crazy, I'm gonna do it this way, where I write the factors first. If you've done these for half an hour, because you're sitting down and doing homework and you're on a roll, then you can write them this way and it's gonna be fine. But the first time we do this, let's actually write the factors. Okay, so. We have x squared y. Minus, there's gonna be another x squared y. What am I multiplying x squared y by in this corner.
X.
There's another X,
It's cute.
Why?
and there's another Y. Everyone okay with the top?
Okay, yeah.
And now on the bottom, there's an X squared Y. What are we multiplying it by?
X what?
Just a -1.
Oh.
That's it. And this one, there's a 1 by it. It's just hiding, right? Because anything is itself times 1. So now I can say, let's cross off the X squared Y from all of these. Exactly the same as crossing out the 4 from those up there. And what's left? We had the 1, so it was really times 1. We had the minus XY. And we have a -1. When you divide by -1, that just flips the sign of everything. Remember that from some older math class? So we wind up with a -1 and a positive XY.
How, okay, so
So the tricky part was, how did I look at it and know that the X squared Y was going to be the part in common?
Is there another way to solve that?
And let me answer my question before yours. So how did I know that? Because I looked and said, what's the biggest X always gets to? And that's X squared. What's the biggest Y always gets to? Well, only one Y. If there was some numbers, I would do the same thing. If there was a 20 and a 4 and a 2, then I would pull the 2 out, because that's the biggest factor in all of the numbers. So I'm thinking like greatest common factors, knowing what will eventually cancel. Is there another way to do this? There's. If I gave you. 20 minus 5 over 5. You could make that 15/5. Or I could break it apart into two things and have the 25ths minus the 5/5. Right? So I could do that same thinking with this top thing. I could make it x squared y over negative x squared y minus x cubed y. Actually, if I'm putting the minus up here, then I don't need to put it there also. Let's just keep it a plus. So now when I cancel, x squared is gonna go away, y is gonna go away. That's just something over the negative of itself. So that's -1. And then this one, x cubed and x squared, well, two of the x's cancel, the last one sticks around. And
That's.
whoops, that should have been a squared there. Same thing. One of these y's cancels, the other one sticks around, and the negative signs cancel out. So what I wind up is an x and a y.
Okay. Okay, it's actually not too bad.
And if there's a third way, it's not coming to mind. You either treat it as a division problem mainly, top divided by bottom, that's what we did here. Or the bottom one was we treat it as a fraction subtraction problem mainly, and you're just simplifying the fractions that you're subtracting. Should I write that? That'd be nice. Okay, let's grab another one and have you do it. And we'll compare our answers.
$26.
26. Oops. Okay, try 26 on your own paper. Sure, then I'll do it both ways, because I can tell that we have some people that like one, some people that like the other way.
I don't like it, that's the good answer.
Okay, again, if you were a Zoomy, then do like a hand or a thumbs up or say something in chat or wave in a camera or something, so I know. It's a good time to move. Make a smiley face on the whiteboard. It's making pancakes, this is my time.
I don't like it.
Sorry. Did you like the chocolate or the fruit cake?
Oh, no, I like things.
Pancakes, you don't like the
I
math.
don't like this.
Okay.
Oh,
Oh, then do pancakes.
So the
I didn't know the
pancakes were good.
pancake too.
No, I like those.
That was pretty good.
Well, try it both ways, just pick whichever way made more sense, do it that way. Oh, I know what I should do to make things match. I should write this as plus or minus 5. That's okay.
I don't understand the written part. I really got it when it's multiplication, like that one was really clicking for me. Then
Then don't worry too much about this.
division,
This is mostly to like stretch your brain before thinking about factor. So if you don't get this, that's okay. Okay, I'm gonna do this both ways. Let's see, few I'm ready's, and it's also just not that important. So if I want to do it the division way. I'll call it division and canceling. What's the biggest thing that's gonna cancel out of all three parts?
X's.
More than just the X. How many X's?
Well, there's 3 total.
But
But
what,
I guess technically 2.
of the 12, the 18 and the 6, what's the biggest common?
Oh,
factor?
that's what you're saying.
Yeah,
18.
18.
no, 18 doesn't fit with 6.
-5. So it's a 6.
It's the six, yeah, so six x's are gonna be everywhere. So there's six x times something, and there's six x times something. And there's six x times something. I'm just writing my brain going, okay, so at the bottom it's -1 times the six x. What's happening on the top left? We have a 2 to get 6 times 2 is 12. But we have more x's than just that one? No, just that one x. And then we have a y squared. Okay, there we go.
Wait. That part lost me completely.
I do understand.
Oh,
Yeah,
okay.
yeah, it's just the bit,
Got it?
it's just writing it out, so
Okay,
it makes sense.
You're, okay,
And then how about the top right?
I mean, you mean 3.
Yeah, I need a -3 to make it a -18.
Is it though, because is it -6x?
I could have tried taking a -6 out of all three, but I picked a +6x, because for my brain that works better.
why?
If I had picked a
Okay.
-6x, this would be positive here, and that would be negative
But
there.
you'll get the same,
I'll get the same thing.
okay,
Okay, now the six x's all go away. And what I have left is 2y squared -3 over a -1,
okay.
and that's going to be at -2y squared plus 3, because dividing by -1, just like multiplying by -1 makes it a positive or negative switch. Okay, or if you like the fraction addition. Then this is 12 xy squared over -6x plus a -18x over -6x. Again, I am picking to have a plus in the middle so that I am keeping the negatives, if there are any, on the numerator or denominator rather than sliding them to the front of the fraction.
So I just did the opposite of that, and that's what messed up my my
Ah.
positive 3x at the end, cause I kept it -18 over -6. But then when I divided them, I forgot to divide
Right.
-18 by 6.
Okay.
I honestly did it different in both these ways, still got it right.
Okay, good. So 12 and 6, well, that just becomes a 2 on the top, divide top and bottom by 6. X's go away, y squared's still there.
Hmm.
And then 18 and a -6. That'll just be 3 times 6 is 18. And oops, I forgot the negative down there, that's why it's.
It's always intimidating when you have two of those variables like buddied up together next to a number.
Yeah,
Cause I was hesitant when I was doing it, if I could
It
actually,
is intimidating,
like,
but then you just.
if I could cancel out the x
Yeah.
between the y and the number, like. Wasn't 100% if you could do that, but I rolled with it.
It's learning, if you got it wrong, it's no big deal anyways.
Sorry about why.
Okay, I don't want to spend more time on this, it's not that important a
Okay.
topic. But there you go, you have seen it. Check the ones in my open math, I wouldn't be surprised if the ones they gave you are kind of the easier ones, because that's what the GED would do with it all. Okay, moving on, we don't have much time, but we can start. Next one. I will again put it in chat, so you don't have to follow my clicking through. What's happening? Okay. Away. We'll play the factor game and stuff, wonderful.
I think that happens once a week. Someone tries to walk in our room and realizes it's the wrong room.
Okay, what am I trying to do? I have to get the share link. Okay. Should we do roomies versus zoomies, or do you want different teams? I could just roll some random dice and see who's on which team. People with hats versus people without hats.
That's prejudice.
Yes.
Okay, roomies, let's do it. Roomies versus zoomie. Okay, so team X's. That's the roomies. Team O's. Okay. So how this game works. This is the best way I know to practice mental arithmetic, mental multiplication and division and factors. You could just like do something else with flashcards, but flashcards aren't fun. So this is good if you want a little brain exercise like the day before your GED. Or if you have kids that are going through the school system and they're trying to learn their times tables, this is the fun way to practice with them at home without driving yourself and them crazy with flashcards. So as an example, roomies, somebody grab your X and move it to any spot on the board. This won't be your actual play, we're just doing a sample turn. So if you picked 15, if that really was your choice, then the other team would get to react and pick all of the unclaimed factors of your number. So what are factors of 15?
Right.
They could pick 3. No, what am I? No, that's not what I'm doing. Why would even is that? Yeah. There we go. I'm just gonna have to copy that shape. Okay, there we go. 3 times 5 is 15. What else?
1 times 15.
1 times 15, so 1 would be claimed.
Like, there's another one?
30 divided by.
Then, if you're playing it to be mean, maybe because you're a parent, then if the other team forgot a factor, you would get to go ha 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 and claim it. But we're just going to help you until you get all the replies. So that was the X is starting and the O is replying. Make sense? Then we switch. Now the O's get to pick any number on the board they want that's not claimed yet. And the X's would get to claim the factors that aren't claimed yet. And when you're done, you're gonna add up all of the numbers under your shape. So the 30 square is worth a lot more than the 2 square.
Okay, so you want that.
So you want big numbers, but the big numbers also tend to give the other team more factors, so that's the tension. So I'm gonna lock this so that we don't keep sliding the board around. I'll move these over here for now. You'll need to make more copies of your shapes, obviously. Hopefully it will work better for you than it did for me. Okay. Why don't we have roomies go first? So agree, talk together. But also remember the other team can hear you, so if you say something like, don't pick 30, it has so many factors, that you're kind of giving them a tip also. So
G 29. Okay. Cause that's the big one, but honestly, no, it's big factors.
29, okay, what factors do the zoomies get? I'm gonna pull everyone here, by the way, just in case your cursor is lost. They get at least one thing. one of the zoomies, grab an O and move it to the factor that you get. Yeah, because 1 times 29 is 29. Okay, so that was X's starting and O's replying. Now O's, talk to yourselves. But again, remember, we can hear you. So unmute or type in chat and agree on a good number to claim anywhere on the board that's open. In chat, Vincent says 17. If other people like 17. Yeah, okay, somebody move it on to 17 then. Okay, do the roomies get any factors for 17?
Don't believe so.
What do we call, by the way, these numbers that only have themselves? in-
Prime numbers, right?
Prime numbers, okay, so primes are strategic. If you play this for little kids, it takes them a few games to figure that out. They feel all smart. Okay, back to X's starting. You didn't get a reply, but you now get to pick any number you want.
We should check the higher prime number.
13 prime number.
It is. So you want higher.
Let's go with 13. Huh? Should I say we'll go 13?
Okay, we can go 13.
Okay, 13 is prime, the O's don't get anything. Okay, zoomies, any number you want. In the chat, Vincent says 11. If people want more pancakes for the road, we'll start making them.
Wait, these prime rate.
Dream.
You sure? You guys are lose prime rate?
Oh, yeah.
Okay, so O's did 11, no reply, X's are doing 23. There won't be a reply, soon we're gonna run out of primes. Or they'll just get so small, it's not worth it. So maybe you would get a better net gain by picking a big number that doesn't have too many factors. Okay, O's, do a copy and paste on one of your O's. And once you get another actual thing to move around, put it where you want.
There you go. Whose turn is it?
It's O's turn. Zoomies, they can pick any spot they want. 7, let me give you a hint, and then I'll call time because it's time to be done. If you pick 7, they would not get a reply. But you only got 7 points. Whereas if you pick, for example, 25. What would the roomies get?
We would get 5.
5 and only 5, right? So you're ahead by 20 compared to them.
They
You
also-
get 25. It's not true that all perfect squares are safe. If this board went up to 36, 36 has a lot of factors. So just because it's a perfect square doesn't mean it's a great play, but sometimes it means it's a good play. So we're not gonna do this too much more. This is just to get your brain going with factors. And again, to help you if you have kids in school. But there we go, that's the factor game. Okay, now. When we meet on Thursday, we're going to work our way up to factoring polynomials. And just like we started tonight, by multiplying plain numbers and using kind of the routines and patterns and systems we saw to then deal with polynomials, we're going to do the same thing. So there's something called the horseshoe method for finding all of the factors of a number. If you looked at factor trees, people tend to remember factor trees better. That's not what we want. We're gonna review them anyway, because otherwise somebody's really gonna want to talk about them because their brain is not happy until it's done. But factor trees are not the right tool. They find the prime factors, but they don't find all the factors. And we want to find the whole list of all the factors. Then there's some logic puzzles, which say things like, what are two numbers that add to 7 but multiply to 6? They add to this but multiply to that. So
Cool question.
sometimes it's negative. What are two numbers that add to negative 25? But multiply to 144 and so on. And that is actually the thinking you need to do the factoring. So the last step will be, how do we undo this? I'm going to use the boxes because visual will probably help. Foil was everyone's favorite for doing the multiplying, but it was sort of a shortcut. And a shortcut isn't the most useful thing for looking at how all the pieces fit together. So rather than use foil backwards, we're going to use the box method backwards to see how to break apart polynomials. If they started with something, and you could see maybe if your font is big enough up at the top here, 4x squared plus 12x plus 9. So if you start with that, how do you break it apart? There's actually a very straightforward process. These are not scary, hard problems, because you're not sure what to do. They only are as hard as the logic puzzle things that you saw above a moment ago. But if you get good at those little, what are numbers that add to this and multiply to that, then you just follow the process. It always gives you the answer. Life is good. As before, when we are multiplying, the tricky thing that you'll get wrong answers, and that the people who design multiple choice problems will give you wrong answers that look tempting, or when you forget that 2 negatives make a positive, or there's only 1 negative here, so it's negative, or so on. So at the bottom, we're going to look at all of those cases where, there's a negative here, there's a negative there, and so on, because that's what's going to mess you up. But the process itself is nice and straightforward. We're going to look at it, why it works with the box. For the actual process, you can take a box with 4 corners. And then there we go. So that's tomorrow, not tomorrow, Thursday's class, and then you can factor. Yay. Okay, any questions from the Zoomies?
No, I don't think.
Okay, so you have 2 days, work on homework if you can. Don't rush ahead, right? If we haven't talked about things yet, like this factoring, but don't pay that homework. unless you really have a lot of time for some reason. But do the catch-up stuff that you were behind on, and then I'll see you Thursday. I'm gonna stop the recording. If you've had questions, just want to ask them while we're recording, but that's.